Alright, so now that we know what functions and relations and domains and range are for a bunch of different situations, let's go back to the math. So usually when we're dealing with math, we're dealing with equations. So right now what I have is I have 5 relationships, right? So y is equal to this line, y is equal to this parabola, y is equal to this cubic, y has this absolute value, and then y is equal to this rational function. So I have 5 different relationships. And one of the exercises I usually do in a classroom is I ask my students to find y when x equals -3. And to really get everybody scared, I tell them they have 30 seconds to do it. And if they all get the right answer, we can all leave early for class. And of course, usually students want to do that, but what starts to happen is they start to realize, what you guys are probably asking yourself right now, or at least I'm hoping you're asking yourself, is, well, which one does he want? Right? Because if I put a -3 here, I'll get a y value. If I put a -3 in here, I'll get another y value. If I plug it in here, I get another, and so forth and so forth and so on. So the next question is, which you guys should hopefully be asking, is which one? Alrighty? And so what we've done then, so because a lot of times in mathematics and engineering and science and even in business, we have probably 5 or 6 different relationships working together to model a situation. So to know which relationship that we're talking about, what we use is famously known as function notation. And basically all we're going to do is replace the y. We're going to replace it with the symbol f of x. That's how we read that statement right there. So all we're going to do in a moment is replace our output y with this funny looking function notation f of x. Now the first thing I want to mention here is this is not multiplication. I'm not asking you to multiply the f to the x. What I am telling you is that the f represents the name of the function, and the x telling me what the independent variable is. It's basically telling you what f depends on. And then the rule is given by what you see here. So this is how this is going to work. Rather than calling this y, I'm now going to call it f of x. And so now I'm distinguishing this rule from this one because I've given it the name. The x is telling me that this function depends on f, or excuse me, this f depends on x, and here's how it depends on it. We're going to multiply it by 2/3 and subtract 1. We can keep going in our alphabet, right? If this is f, how about we call that g? So I'm replacing this y with the notation g of x. So now I've called the relationship g, and it also depends on x, and here's how it depends on the x. We're going to square it, subtract it, and then subtract 6. So a different relationship, a different name. So this is my function f of x, this is my function g of x. And we can keep going, right? How about we call this h of x? So my cubic function, right, is now called h, and it depends on x, and here's how it depends on that independent variable, right? We're going to cube it and subtract 4 times it. Since this is an absolute value, how about we call that a of x, right? So my a function, depending on x, is 3, take away the absolute value of it. So a different function. And since this is a rational expression, how about we call that r of x? So the function notation is basically replacing our y. So we have an old way of doing things and a new way of doing things. So old way, I would say find y when x equals -3. The new way is to say something like this. Okay? So we literally read this as a of -3. But what it means is this is the input, and we're putting it inside of the function a. So in language, it basically means that. So what is the output of the a function, right? What's the y value of the function a when my input is -3? And you're basically going to do the same thing we did when we were graphing. A of -3, I'm going to go to that relationship right there, right? Because we've signified that it's the relationship a. And I'm going to replace the x with -3, because that's what they're asking me to do. Put a -3 inside of the function a. Now we do a calculation. Absolute value of negative 3 is 3. 3 take away 3 is 0. So we're basically saying that y is equal to 3 when x is equal to negative 3. Or in a ordered pair form, right, we're saying when my input is negative 3, my output is 3. Or functionally, I'm saying when you put a negative 3 into the a function, the output is a positive 3. So lots of ways to say the same thing we were saying over there. So if my input's negative 3, find the output. I just did it. And hopefully it's very similar to what we were doing when we were graphing. It's just the only thing I've changed on you is we're no longer calling y, we're giving it a function name. So let's play that game a couple more times. So the old way, right, of saying something would be to find y when x equals, let's say, 0. Right? So again, if we use this old way, you'd have to come back up here and say, well, does he want me to put 0 here? Does he want me to put 0 there? Does he want me to put 0 there? Here, you know, which one? Which one does he want? And so that's why we're going to do it the new way. Rather than saying this, I will say this. Okay, again, we read this as g of 0, but what it means, right, so that's how it reads, g of 0, but what it's telling you is put the 0, use that as the input into the function g. So I'm going to go to the function g, right, there it is right there, and I'm going to replace the x with 0, because that's what it's asking me to do. If I let 0 be the input, what is going to be the output? And so what we're saying here is that y is equal to negative 6 when x is equal to 0. Or in an ordered pair, we're saying when my input is 0, my output's negative 6. Functionally, we're saying if you put a 0 into the function g, your output, your y value, will be negative 6. Okay, so again, the input is in the parentheses. I'm literally, you can almost see it in the notation. I'm asking you to put negative 3 into the function a. I'm asking you to put 0 into the function g. So rather than saying this, I just say that. It's a little bit more concise, and it also tells me which relationship we're going to use. So let's do this one more time, and then I'm going to cut to another video and we'll do some more. So let's do this. Let's find y when x is equal to, let's say, 5. Alright, so again, if we use this notation, you're wondering, well, which relationship is he talking about? But if I say it this way, hopefully you know exactly what I'm talking about, right? So we're putting our input is 5, right? So x is 5, but I know where I'm putting it in. I'm putting it into the function h. So I'm going to go up to my function h, there it is, and wherever I see an x, I'm going to replace it with 5. So we get 5 cubed, 4 times 5. And do the math. I think that's 125 minus 20, which gives us 105, I believe. So we're basically saying that my y is 105 when x is 5. Or the ordered pair way, right? If my input's 5, my output's 105. Or the function way, right? Oops, not g. H of 5 is 105. So if you put 5 into the function h, the y value, or the output value, will be 105. So it's just a new way of saying something old to something new, and the idea is I can work with several different relationships and know which one I'm talking about, rather than trying to figure that out. More practice is coming in the next video.